Good morning, students. Before we start today's topic, I am going to ask some question, and if you know the answer, raise your hands. What is the cause of motion?
Force.
Okay. What is this?
Ball.
And what will happen if I drop this?
It falls on the earth.
Yes. Why this ball fall on the earth?
Due to earth's gravitational force.
Very good. But why the moon does not fall on the earth? Okay. So today we will study about gravitation and universal law of gravitation. In 1665, one day Newton was sitting under an apple tree. Then an apple fell on him. He wondered why this apple did not go sideways or in upward direction. Later on, he thought that since cause of motion is force, so there must be a force, a downward force which is exerted by earth. After that, he also wondered that why the moon does not fall on the earth. Then, after the experimentation and observation, he came to the conclusion that the moon the moon revolve around the sun, earth because of the force of attraction of the earth. He also said that the planets revolve around the sun because of the similar force. He called it this force as gravitational force, and he said that every object in universe attracts every other object, and this force is called gravitational force. Now let's define gravitation. The phenomenon of attraction of two objects in the universe is called gravitation. The gravitational force is always attractive, it never repulsive. It is the weakest force among the all forces in the nature. And the gravitational force is mutual force. What is the meaning of word mutual? Mutual means it is a two-way force. It means if there are two objects A and B, if A exert a force on object B, then object B also exert similar force on object A. That is, it is a two-way force, and this is called mutual force. Now, let's see how gravitational force work by the help of examples. This is a ball, and let's see what will happen if I will throw it in upward direction like this. Okay, what happened here? The ball goes in upward direction and stops at one point, and after that it comes down. Let's see with the help of diagram what happened here. This is the upward motion of ball when we throw it. And earth gravitational force act in downward direction. Okay, what happened here? It is similar to like if you are driving a car and you apply brake. When you apply brake, what happened? The application of brake opposes the motion of the car and it stops. Similar thing happens here. The earth's gravitational pull, that is in downward direction, and the motion of ball is in upward direction, so they are in opposite direction. So this downward gravitational pull opposes the motion of ball, and the velocity of ball decreases gradually, and At a point A, the velocity of ball become 0, and after that point the ball comes down due to gravitational force of earth. Okay. Now let's see another example. This is a ball and I tied it with a rope, and now I am drilling it like this. What is happening here? The ball is in circular motion, and this motion is called uniformly accelerated motion. Why the motion of ball is called uniformly accelerated motion?
Because direction of velocity changes at every point.
Yes, the speed of ball is constant, but velocity of direction of velocity of ball changes at every point of the circular path. So this is called an accelerated motion. Now, if during the ball's motion, if I cut this rope, what will happen? The ball flies off tangentially. Here, the tangential, the direction of velocity is tangential direction. So, in direction of velocity, ball flies off. Now, let's see with the diagram that what happened here. Here, this is a ball and this is rope. Ball is in circular motion. And we know that the cause of motion is force. Here the rope acts as radius of circle. So there must be a force that acts radially, and direction of force must be towards the center. So since this is center seeking force, so this is called centripetal force. And this centripetal force is responsible for the motion, circular motion of this ball. And since the direction of velocity is along the tangent to the circular path, when you cut the rope, the ball flies off tangentially and then ultimately comes on the ground. Okay. Same thing happens in case of moon and earth. If this is earth and this is moon, moon is revolving around the sun, earth. So the earth's gravitational force here acts as centripetal force for the moon, and due to which the moon moves around the sun in circular path. And similar thing happens between sun and the other planets. The sun's gravitational force acts as centripetal force for all the planets, and due to which they revolve around the sun. Now, Newton gave a law that is called universal law of gravitation. Let's see what is that law. Universal law of gravitation. According to universal law of gravitation, every object in the universe attracts every other object with a force which is directly proportional to product of their masses and inversely proportional to square of distance between them. Let's see this universal law of gravitation with help of chart. I am showing you a chart. Everybody look at the chart. Here A and B are two objects. Mass of A is m1 and mass of B is m2. Now, according to universal law of gravitation, every object in the universe attracts every other object with a force. That force will be F. Now, object A attracts B with a force F. Similarly, object B attracts object A with similar force F. And distance between center of objects is R. We always take distance from the center of the objects. Okay. Now, gravitational force F is given by capital G m1 m2 upon r square. Now, let's derive this formula. Here, A and B are two objects. m1 is mass of A, m2 is mass of B, and distance between them is r. And gravitational force of attraction is F between them. Now, what the universal law of gravitation say? It says the force between the two objects is directly proportional to product of their masses. It means here masses are m1 and m2. So, force is directly proportional to m1 into m2. This is first equation. What do you mean by proportionality sign? It means if m1 and m2 increases, or if we increase the masses of the object, force of gravitation also increases, and if we decrease the masses, force also decreases. Now, the force is inversely proportional to square of distance between the two objects. Here distance is r and square of the distance means r square. So, and it is inversely proportional. So, we write distance square in denominator. This is equation 2. Inversely proportional means if we increase the distance, force decreases. And if on the other hand, if we decrease the distance, force increases. Now combine these two equations. By equation 1 and 2, F is directly proportional to m1 into m2 upon r square. Now when we remove proportionality sign, it is the right hand side of equation multiplied by a constant. Here that constant is capital G. So after removing the proportionality sign, our equation will be F is equal to capital G m1 into m2 upon r square. This is the formula for force of gravitation, and capital G is called universal gravitation constant. Now let's see what will happen if we increase the masses or the distance between the object. Again, look at the chart. Now, if we increase the masses, let's see what will happen. Okay, we increase the masses. Now masses are 2m1 and 2m2. Mass of object A is 2m1 and mass of object B is 2m2. Now let's see What will be the formula for that? Now, if we double the masses, then what is the formula for gravitational force? It is Gm1 into m2 upon r square. Now, in place of m1 and m2, we put 2m1 and 2m2. So, here the equation will be F is equal to G 2m1 into 2m2 upon r square. Now 2 into 2 is equal to 4. So we write it like this: 4 into G m1 m2 upon r square. Now the quantity G m1 into m2 upon r square is F, gravitational force. So we replace this quantity by F. So the required force is 4 times than the previous force. It means if we double the masses, then force of gravitation will be 4 times. Okay. Now let's see what happens if we increase the distance. Now I increase the distance. Let's this distance between the objects now is 2r. That is, we double the distance. Then if we double the distance, then what we will do, in the place of r square in our main formula, what we write? 2r to the power 2 means 2r whole square. Now our equation will be G m1 m2 upon 4r square. Now the quantity G m1 into m2 upon r square is gravitational force. So in place of that we will write capital F. So our formula will be F is equal to 1 upon 4 F. It means if we double the distance, the gravitational force will be 1/4 of the previous force. Now we will find out the unit and value of G. Now what is the unit of force? It is Newton. So formula for the gravitation force is G m1 m2 upon r square. Now unit of gravitational force is same as force, that is Newton. Now what will be unit of capital G? That is universal gravitation constant. So do cross multiplication. So G will be F into r square upon m1 into m2. Now put the units of all the quantity here. F is, unit of force is Newton, unit of distance is meter. Here distance square means meter square upon unit of mass is kg. Kg into kg, that is Newton meter square upon kg square. So unit of G is Newton meter square upon kg square. And value of G is given by the scientist Henry Cavendish. Okay. And what is that value? That value is 6.673 into 10 to the power minus 11, and unit is Newton meter square upon kg square. This is value and unit of G. So today we have studied about gravitation, definition of gravitation and universal law of gravitation. Now I will ask you some questions. What is formula for gravitation? Force of gravitation.
F is equal to G m1 m2 upon r square.
Good. What will happen to the force of gravitation if we increase the distance?
Force of gravitation will decrease.
Very good. Now I am going to give you classwork. So students, this is your classwork. You have to do all this question in the class. These are fill in the blanks. First is dash gave universal law of gravitation. Who gave universal law of gravitation? Now unit of G is dash. What is unit of G? Force of gravitation is dash among the all forces in nature. Means how is the gravitational force? Gravitational force is always dash. Means what is the nature of gravitational force? Heavier the masses, dash is the gravitation force. Means if we increase the masses, what will happen to gravitational force? And this is your homework. You have to do all this question at your home. Question 1 is derive formula for gravitational force. Second is if distance between two objects become 1/4, what will be the force of gravitation between them? You have to find out that. Okay. Thank you and have a nice day.